Hey everybody, and welcome back to another video. Today we're going to be talking about the importance of feedback loops when treating tinnitus at different levels, what they all mean, and what does this actually mean for future treatments. So briefly, we're going to be talking about the dorsal cochlear nucleus, as you can see right here at the base of the brainstem, so to speak. The ventral cochlear nucleus right here. We're also going to be talking about the inferior colliculus, the medial geniculate nucleus, or the medial geniculate body, also known as a part of the thalamus, and of course about the auditory cortex, which is where we actually perceive our tinnitus at the end of this long and complex neural pathway. We are going to be talking about the feedback loops, or the ascending and the descending projections, basically. Now, as we all know, the dorsal cochlear nucleus, which is at the base right here of this diagram, is where sound from the auditory nerve is processed and combined with somatosensory input, or input from the trigeminal cervical complex, as I mentioned in the previous videos. Basically, nerves from the face and nerves from the neck. And as we all know, when this process glitches out due to excitotoxicity or inflammation or somatosensory issues like whiplash or cervical tension, jaw tension, anything like that, it can actually lead to a cascade of hyperactivity. Very important for me to remind you all that while the dorsal cochlear nucleus is generally the source of tinnitus generation, so to speak, or as you can see on this diagram, the nerve signals come from the auditory nerve fiber to the fusiform cells, the dorsal cochlear nucleus, and excitotoxicity that is kind of passed down from the cochlea down to the dorsal cochlear nucleus can cause an excitotoxic shock, which leads to the damage of the fusiform cells or associated cartwheel cells, as you can see here, which then can lead to maladaptive plasticity, or basically failed homeostatic plasticity, which means that the brain fails to reorganize itself correctly due to a combination of different factors, like I mentioned before. These factors could be somatosensory factors like again, problems with your somatosensory pathways, tension, etc., etc. So, and it's also very important to keep in mind that the thalamus, or the medial geniculate body, is actually also very important as well in this process. So I'm talking specifically about the descending projections from the MGB, for example, to the auditory cortex, eventually back to the inferior colliculus, and eventually back to the cochlear nucleus, as you can see here. So it's not that the dorsal cochlear nucleus is only affecting the higher regions of the brain. It is also a fact that the thalamic-cortical, I guess you could say, gating does actually indirectly have a descending effect on the cochlear nucleus too. That means that any irregularities in any part of the auditory pathway, whether that be descending projections from the midbrain regions, or whether that be ascending projections from the cochlear nucleus, any disruptions or any irregularities in any of these structures can eventually cement the maladaptive plasticity as the new kind of normal levels, I guess, for the auditory pathway, or the or the brain in general. And that's exactly why, for a lot of people, tinnitus persists for many years, is that the constant irritation or the constant issues of all of these cofactors, somatosensory, auditory, anything, constantly reinforces these feedback loops, as you can see on the diagram. And as you can see here, disrupting these feedback loops at any one of these points could potentially lead the brain to accept a maybe lower level of hyperactivity as the new norm, basically, aka the tinnitus decreasing permanently. Now, the ventral cochlear nucleus is responsible for the precise timing and intensity coding of incoming sound. The bushy and spherical cells preserve temporal fidelity, basically aiding in sound localization and clarity, volume of sound perception. And as we know from Susan Shore's research, the bushy cells are actually implicated, or the abnormal firing rates of bushy cells in the ventral cochlear nucleus are implicated in hyperacusis, or loudness hyperacusis. Now, as we ascend further, the inferior colliculus, as you can see right here, in the midbrain, it acts as a major integration hub. It processes inputs from the dorsal cochlear nucleus, ventral cochlear nucleus, and other brainstem nuclei. What it does is that it refines and shapes the signal before it relays it upwards. And above the inferior colliculus is the medial geniculate body, or the MGB of the thalamus. This serves as a very important relay to the auditory cortex. And the MGB, it further refines the frequency and temporal representations, and it actually influences how sound is perceived at the cortical level, or the auditory cortex. And as I mentioned before, all of these structures are interconnected by both feed-forward and feedback loops. So hyperactivity and maladaptive plasticity in any one of these structures can propagate through the network and maintain the pathological status, or the pathological state, like tinnitus or hyperacusis, for example. In fact, and I've seen this happen before, tinnitus doesn't only arise from bottom-up hyperactivity, like I mentioned before, like excitotoxicity in the cochlea, but it also can be very strongly influenced by top-down projections from the MGB. So that means a person who takes a lot of drugs, for example, I don't know, like weed or just whatever, could potentially either exacerbate or even cause the hyperactivity or maladaptive plasticity, or this hyperactive state being cemented as the norm all the way down in the dorsal cochlear nucleus. Now, the dorsal cochlear nucleus and the ventral cochlear nucleus do not directly synapse onto one another, but their activity patterns eventually do meet and shape each other's influence indirectly through shared targets and feedback projections from the higher centers, like the inferior colliculus. And as you can see on this diagram from Susan Shore's paper, you can see that the auditory nerve fiber kind of diverges and sends the auditory signal to the dorsal cochlear nucleus and the ventral cochlear nucleus separately. And this processing is done separately and then connected, I guess you could say, in the inferior colliculus. Probably wondering, well, if the ventral cochlear nucleus is responsible for hyperacusis and the dorsal cochlear nucleus is responsible for tinnitus, then how the hell did the Susan Shore device help people with hyperacusis? And how does hyperacusis improve sometimes when tinnitus does not improve? Well, to answer the first question, actually, as you can see, the convergence of signals happens in the inferior colliculus, and these feedback loops, or these descending projections from the inferior colliculus, can actually affect the cochlear nucleus as a whole. So there are descending projections from the inferior colliculus both to the ventral cochlear nucleus and the dorsal cochlear nucleus. So that means while potentially disrupting this heightened synaptic activity between the, for example, parallel fibers of the granule cells, or, the somatosensory SP5 pathway, and the cartwheel cells and the fusiform cells, if we disrupt the, or decrease the heightened activity at these synapses, potentially this could cascade to the inferior colliculus, from the dorsal cochlear nucleus and then be passed down through the descending projections to the ventral cochlear nucleus, aka treating tinnitus with Susan-Short's device will have an indirect effect on decreasing the firing rates of the bushy cells, for example, in the ventral cochlear nucleus. Indirectly, so to speak. And this is confirmed because we've had many people have their tinnitus actually decrease due to using the Susan-Short device. And as we all know, the Susan-Short device only affects these synapses right here. So this is kind of proof of the ripple effect, basically, throughout the auditory pathway, where disrupting the feedback loops in one particular area can potentially have an ascending and descending effect throughout the whole auditory pathway. And this is also the same for disacusis. Now, we don't exactly know why disacusis happens. There's many reasons, but there are some theories that state that disacusis could be on the inferior colliculus level or, for example, in the ventral cochlear nucleus level. But we know that Susan-Short's device from many cases can actually, well, not many actually, only a couple of them, actually does suppress disacusis. So that is further proof of this disruption of feedback loops having a ripple effect on the auditory pathway in a descending and ascending order. The explanation is that coincidentally the spike timing or the spike timing dependent plasticity or the long-term depression, which is initiated by the Susan-Short's carefully timed stimulation of somatosensory and auditory nerve fibers could potentially also decrease the synaptic strength between the somatosensory pathways and the bushy cells in the ventral cochlear nucleus. But I don't think that's the case, but it definitely could be. I mean, we see lots of people's loudness hyperacusis improve with time while their tinnitus does not. And this is explained, of course, by the divergence of the auditory nerve signals to the VCN and the DCN. So I guess you could say that is also a viable explanation that the spike timings are just like similar to, these synapses are similar to these ones. That's also an explanation. There's other researchers who are researching actually gamma oscillations or gamma brainwave oscillations and their implications in hyperacusis, for example. So these types of treatments, which are being researched, are not at a synaptic level like Susan-Short's research, for example. But in any case, as I've already mentioned before, disrupting feedback loops in any one of these structures, and the gamma brainwaves are closely associated with the thalamus. This is also actually a potential, very good potential treatment. Like, I mean, like you might think that treating the synaptic activity at the lower levels might be better, but in general, if you disrupt the feedback loops in any one of these points, even in the thalamus, it would lead to potentially the hyperactivity decreasing like overall. So this is not something that should be ignored. It is excellent research that is being done. So temporal coding and gain control mechanisms absolutely should be studied and researched as potentially alleviating tinnitus, maybe hyperacusis symptoms. Basically, overall, by carefully inducing long-term depression or by addressing some of these temporal gain control mechanisms, you can disrupt the pathological reinforcement loops as seen on the diagrams, and you could thereby restore more balanced synaptic firing patterns, for example, and the overall result will lead to a reduction in aberrant hyperactivity, improved signal fidelity, and potentially treating or alleviating both tinnitus and hyperacusis and anything associated with this. So in any case, a multimodal approach is absolutely necessary for full alleviation of these conditions. But that does not mean that, for example, the Susan Shore device alone wouldn't be enough. We have seen cases of full suppression being consistent. So this video overall is just to have you all understand the complexity of these conditions and what needs to be done to address them. So that's about it for today. If anybody is interested in discussing any of this further, you are free to join my Discord server, where we have scientific discussions on a day-to-day basis, and we have a lot of knowledgeable individuals there who are ready to help answer any of your questions at any time. The links to the Discord server will be in the description and in the pinned comment. See y'all later.